And we should be live. We should be live. Now let's go ahead and take a look at YouTube. Let's see what it's saying. Yep. We are live. So in this video, like I posted, I'm going to be over port address translation, static NAT, IPSec, BGP redistribution with OSPF, and all of that good stuff. So with that being said, let's go ahead and make this a little bit bigger, or just zoom in a little bit. There we go. So in this video we have configured, I need to make it better so you guys can see what I'm doing. Well, what I've done, we have configured so far Ether channels, trunk links, VLANs. We configure VLAN 3, VLAN 4. We configure DHCP. We configure router on the stick. We configure HSRP, which we remove. Then we configure VRRP. Then we remove it, and then we kept GLBP. We configure GLBP. Then we configure OSPF right here between router 6 and router 13 and router 5. So right here we're running OSPF. So now we want to run BGP to go outside. So that's what it is going to happen right now. Let's go ahead and move this down here, and let's keep this one right here. So we are going to be configuring all of that. So PAT, NAT, IPSec, BGP, and we are going to be redistributing OSPF and BGP. So OSPF is going to go into BGP, and BGP is going to go into OSPF. That's how it is going to happen. So let's go ahead and start with this configuration, guys. So the first configuration that I would like to do, it is going to be the PAT. So we are going to be configuring PAT for this network right here, port address translation, and which is basically when you use a single public IP address for all the internal private IP addresses. But different ports is assigned to each private IP address. This type of NAT is also known as NAT overload. So we're basically going to do NAT overload. Let's go ahead and remove this and say PAT/NAT overload. That's what we're going to be doing. I don't know why it keeps cutting off. For some reason it keeps cutting off. Let's see if we close the lab and then we open it again and see if that helps. I don't like it why it keeps cutting off my text. So which one was the one that I was working on? Today is July 9th, and I think it's this one. Let's go ahead and open. Let's go ahead and see that. Yep, that's the one that we are using. I even forgot which one was the project that I was working on, because as soon as I log in, it just brings me back. There we go. Now it looks better. If we close if we close it and open it again, now we can see everything. So PAT, NAT overload, that's what we are going to be configuring. Let's move this over here. And I also, you know what? I also want to get rid of this IP addresses, because these IP addresses should be private IP addresses, not public IP addresses. So let's go ahead and do that. Let's go ahead and remove those public IP address and make them private IP addresses. So we are going to be using 172.16.3.2 over here. Let's make this bold. So that's what we're going to be doing too, because I made them instead of private, I make them public. Let's go ahead and so we don't get confused, so people don't yell at me for doing that. 172.16, that's 4.1. So okay, and this one's going to be 172.16.4.4.2. So let's go ahead and make those changes. Let's go ahead and go to router 6. So we need to remove it from OSPF and add this new OSPF, and also change the interface IP address. So let's go ahead and do that real quick. So let's go ahead and enable config T interface gigabit 0/2 IP address 172.16.3.2. That's just going to remove what I had before. Okay, you can see the OSPF went down. That's fine. Let's do show IP or do show. I don't even need to do let's just do show run, so I can see the OSPF configuration. I think it was OSPF press ID I forgot what it was. Press ID what? Press ID 1. Okay. And the one that I need to remove is going to be, we are going to be removing this network right here. So let's go ahead and just negate this network. Say no, I don't want this. Oh, we need to first go to router OSPF 1, and then we should be able to negate that. And then we are going to add network 172.16.3.0 255 area 0. Okay, let's go ahead and just save my configuration. Hello team, what's up? Now let's go ahead and go to router 5, and let's do the same. Config T, let's see if I know how to spell. There we go. Interface gigabit 0/3 over here. IP address 172.16.4.2 255.255. Hello, man. That 255.255.0. Let's do a show run. I think if I do include OSPF, it will only show me the OSPF. Press ID 1. Okay, thank you. So router OSPF, press ID 1 OSPF, not OSFP. Let's say no network. I believe it was 20.1.4.0 255 area 0. Then we could add network 172.16.4.0 255 area 0. Now let's go ahead and change it in router 13, and then router 13, the ISP should then have those synchronized with OSPF. So config T, interface gigabit 0/2, IP address 172.16.3.1, which is this one right here. Let's also go ahead and change .3, and let's do 4.1 for that. And now we can go to, let's do show run, and let's go ahead and include. So I just want to see what is the OSPF press ID. I think it's 1.2. Yep, press ID 1, router OSPF 1, no network 20.1.3.0 255 area 0, and then we also need to negate 20.1.4.0. And then we can add the new ones, network 172.16.3.0 255 area 0, and then we're going to add that 4 in here, and that we should have OSPF up and running. There we go, OSPF up and running. Great. And let's show IP routes. There we go. So now we just got rid of those public IP addresses, and then we just added the public. We removed the private, we removed the public, and added just private IP addresses. That looks better, and it looks like it is it is the local area network, right? So that is good. Let's go ahead and just save my configuration. So after that is done, we can go ahead and start with we are going to start with NAT overload. So let's go ahead and do NAT overload. So for NAT overload, the first thing that I need to do is you need to specify which one is going to be your inside and which one is going to be your outside. So my outside, if we go ahead and plug in 13 with router 12, which we're going to be using, let's say 1 and 1 over here. And then the public IP address that we're going to be using, because we are using BGP, it is going to be, now we can just use, we can go ahead and use 20.1.1 network. 20.1.1, that's 1. Let's duplicate it. 20.1.1.2 over here. Let's go ahead and start this router up. Now let's go ahead and go to router 13 and go into interface gigabit 0/1, IP address 20.1.1.1 255.255.255.0. do a shutdown, don't forget. Then we are going to specify that this one is going to be my IP NAT outside. Okay, so I'm telling network audio translation that this one is going to be my NAT outside, right? Gigabit 0/1 is the one pointing to the outside. Okay, like that. And then we're going to interface gigabit 0/2, and we are going to tell it that this one is going to be my NAT IP NAT inside. After we do that, the next step that we need to do is we need to create an access list, and we are going to create access list 1, and we want to allow 192.168.3.1 to be NATed, and also we want to NAT 172.16.3.2.3.0 network. So let's go ahead and do that. Create the access list. Access list 1, we're going to permit 192.168.3.0, and we also need to add this network over here is going to be NATed as well. So we need to add all 4 networks. So we are going to permit this network. We also need to permit the 4th network. We also need to permit the 172, the 16, the 4th network, and 172, the 16, the 3 network to be NATed, right? So then after that, all we have to do is do an IP NAT inside source list. So we do an IP NAT. I believe we need to specify that the inside translation, we are going to be using source list 1. So we are specifying that it's going to be an inside translation. So from inside, I want you to only allow this source list, which is allowing these IP addresses to be NATed to my interface gigabit 0/1, which is this one. And then at the end, we need to do overload to make a PAT, right? To make a port audio translation, and that's what they also call a NAT overload, because we are overloading that IP address. Okay, so we cannot test this yet because we need to configure BGP. So we are able to get in here. So what we need to do, why this router didn't go up? Let's go ahead and start this up again. Okay, why is that router down for some reason? There we go. Okay, so we need to configure BGP. So what we need to do, we are going to do go into router BGP. We are going to call this 13 because it is router 13. Then we need to specify my neighbor. My first neighbor is 20.1.1.2. The remote autonomous system of this router is going to be router 12. And there it is. So router 12. Then we need to, let's see, I think that's about it. Neighbor, yeah, that should be good. That should do it. So now we need to go into this router. I don't know why it's not working. Again, even G has some bugs sometimes. So I'm just going to close my lab again, and we are going to open it one more time. So, okay, still down. Let's go ahead and start this up. And when it starts, I'm just going to open it. Come on, there we go. So here we go. It is just booting up right now. So we did that BGP. So what we now need to do is we need to wait for router 12 to show up. Basically, we also need to start this one right here, and cannot. Okay, when we start this one, and when it starts up, I'm just going to also open it. Okay, so now what I want to do while that is happening, we are going to connect these two bad boys over here. gigabit 0/2 and 0/2 should be good. And this one will also form a BGP, so we are going to add BGP over here as well. So there we go. So let me see anybody has a question. No questions yet. Okay, so now let's go ahead and duplicate this, and we are just going to make this IP address of 30.2. We are going to duplicate it, and we are going to set that this one right here is going to be 30.1. Okay, there we go. Let's see, go to router 11, still booting up. So that would give me, let's see what else we can do while that is booting up. IPSec. Sound so slow. I'm sorry, the sound is slow. Was that a comment that the sound was slow? Sorry for that. It's a little bit slow. Everybody's on it. So just waiting for router 12. Okay, router 12 is up. Let's say no. Router 11 should be coming up soon. So we say not over here. Okay, let's say also no over here. And I'm just waiting for them to come up and work. Let's go ahead and also do let's go ahead and add another node. Over here we are going to add a IOL, and we are going to add, this one is a switch. You can see right here, layer 2. And we are going to add a switch. Switch. Let's go add this one. Okay, we can go ahead and connect this right here. We are just going to have another topology over here. That should be good. We are just going to keep adding and adding more. And adding more, okay? Let's put it right here. Let's move AAA down here. And this one over here. So that should be good for now. So yeah, IPSec is going to go over here. Okay, so router 12 should be up and running now. There we go. Enable config T. Let's give it a host name of just R12. That's fine. Interface gigabit 0/1. IP address for that is 20.1.1.2, 255.255.255.0. Let's not forget to do a no shutdown. Okay. Now shut down. Let's go to interface gigabit 0/2. IP address 30.1.1.2, 255.255.255.0. Let's give it a no shutdown. And then we can go ahead and configure BGP. So we do router BGP. My AS is going to be 12. We are going to say my neighbor is 20.1.1.1. The remote autonomous system for 20.1.1 is 13, and that should bring up that adjacency with router 13. So router 13 should have that in there. Let's see, and let's show IP route. You can see, well, it is directly connected, so we won't see that, but we will see whenever router 12 connects with router 11. So let's go ahead and go to router 11. Let's go ahead and close this so you don't get confused. Enable. Okay, enable config T interface gigabit 0/2 IP address 30.1.1.1. No shutdown. So that is up. Exit. We are going to the router OSPF, not OSPF, BGP, guys. BGP 11. My neighbor is going to be 30.1.1.2. The remote autonomous system for that network is going to be 12, or for that router is 12. So now if we're going to 12, and if we tell her that we have another remote we have another autonomous system showing up over there, we want to say 11. So that should be syncing up. There we go, up and running. So now if we go to router 13, we should see that's 30.1.1.0 network. Show IP routes. Nothing showing. Okay, so let's go ahead and go to router 12. And router 12, let's say network. We are going to our 30.1.1.0. Mask is going to be my mask 255.255.255. And we also need to do the 20 network. So now if we do a show IP route, you can see right now that we have the BGP route that our 12 is advertising via 20.1.1.2. So now we should go ahead and test. We should be able to test NAT. Oh, not yet. We cannot do. Why can we test this connection? So the reason why is that if we send it, let's go ahead and try it. Let's go ahead and try and see what happens. So if we want to ping 20.1.1.2, we are not able to ping 20.1.1.2. And why is that, guys? Well, we are running OSPF internally. OSPF does not know how to get to 20.1.1.2. Therefore, since it cannot get there, we need to do some redistribution. So we need to distribute our OSPF networks into BGP, and then we need to from BGP we need to distribute the BGP networks into the OSPF, and that needs to be done on our 12, on our 13, which is this one right here. So let's go ahead and do the redistribution of OSPF into BGP and BGP into OSPF from router 13. You can see right now I'm going to leave it right next to us, and this is from Linux 30, which is in VLAN 3. So let's go ahead and do that. We are going to config. Oops. Config. Why am I still in there? Okay. Config T. We are going to go into router BGP 13. Needs to be the same that we configure. And then we need to say redistribute OSPF, and the purse ID that I'm using is 1. Then we need to go into router OSPF 1, OSPF 1, and we need to redistribute BGP subnets. I believe BGP 13 subnets. And after I do that, I should be able to reach. I am not able to reach. Okay, so we are redistributing OSPF and then BGP subnets. Still not able to reach 20.1.1.1. Let's go ahead and take a look at this. Show IP route. Okay, let's go ahead and go into R6. We should be able to see 20.1.1.1 from OSPF external. Show IP route. So we only see 30.1.1.1. Okay, so that's because I did not add that network into BGP. So if we go into router if you go to router BGP 13, in router 13, if you do and say I actually have network 20.1.1.0 mask 255.255.255.0. So now OSPF knows how to get there. There we go. Now we are able to ping 20.1.1.1. So if we stop this, if we go into router 6, and we can see that router 6 only had the 30 network via OSPF E2. OSPF E2 meaning that it is external, right? Let's go ahead and see OSPF. Oh, where is it? Where's E2? There we go. OSPF E2 is OSPF external type 2. Okay, so that's how, because we redistribute it, and that's how it is now working. If you do a show IP route, it should show the 20 network. So now we have 2 networks via external type 2, the 20 network and the 30 network. So that's how you do the redistribution. So we are able to ping to the outside via BGP. Okay, so that's how it basically works. And let's go ahead and save it. Or actually, yeah, let's go ahead and save it. R6. Let's go ahead and save my configuration here too. So we are now redistributing. So now if you go ahead and ping again 20.1.1.2, this is from network. We are pinging from network 192.168.3.0 network, which we added to the ACL for network ID translation for NAT. So if we go into router 13, if we do a show IP NAT translation, we should see that translation over here. The inside 20.1.1.1, inside global. Inside global is this one right here, my local global, and then we have the inside local. Inside local meaning the inside local IP address that it is translating 192.168.3.2, which is that Linux device down here. You can see the outside local. The outside local is the location where it's going to. It is going to this one, and the outside global, you can see it right here too. And now we should also be able to ping from 172.16.3.2 network. Let's do a ping 20.1.1.2, and we should see that translation over here. There we go. We have both translations. You can see that it is allowing the 172 network and the 192 network, 168.3.2. We should also see it from router 5. Router 5 is in 172.16.4.2 network. So if we do ping 20.1.1.2, show translations. Wait, was I able to? Yeah, I was able to ping 20.1.1.2. Let's go ahead and do it again. Yep. So I was able to ping. Let's see if I'm able to ping from Linux 41. Linux 41 has that 192.168.4.0 network. That's where it is. So let's go ahead and ping from here. Ping 20.1.1.2. There we go. I'm able to ping. Show translations. And for the translation, still only showing this one for some reason, which is kind of weird. It should be. What if we do a debug? Let's go ahead and IPSCNP. Let's see what we get. For sure, debug ICM debug. It is debug IP. I don't think we have debug NAT translations. Detail or event. We do it from here. Still not showing up. No debug. Oh, all right. Well, that's fine. Well, we have configured that PAT network, which is port address translation, and we also did OSPF, BGP, and we redistribute BGP into OSPF and OSPF into BGP as well. So that is great. So now what I want to do is that I want to create a tunnel, and I want to create a GRE tunnel between R5 and R12. So let's see how we are going to be able to do that. Before we do that, I want to go into interface, loopback 12 in router 12, and I want to create a interface IP address 12.12.12.12 and IP address. And we also want to add it. We want to add this loopback into BGP. So we do router BGP 12 network 12.12.12.12 net mask router to net mask. Why is it not? So router BGP 12 network question mark. Okay, it's not net. It's not net mask. It's mask. 245.245.245.245. Let's go ahead and save my configuration over here. I also want to configure a loopback address for router 5. Config T. We are going to configure interface loopback address. It is going to be loopback 5 IP address 5.5.5.5.5.245.245.245.245. And we want to say, now we need to add it to OSPF network 5.5.5.5 and then 0.0.0.0.255, then area 0. Let's save my configuration. Let's do R6 as well. Enable config T interface loopback 6 IP address 6.6.6.6 255.255.255.255 router OSPF port ID 1 network 6.6.6.6 255 area 0, and that's my configuration. So let's go ahead and create that. Like I said, we are going to be creating that GRE tunnel. So we are going to start. Let's start with router 6. So I want to configure from 6 to router 12. So the way that you do that, we first need to go ahead and create a tunnel. So let's go interface tunnel. Let's call it tunnel 6 because let's stick with that 6 because it's router 6. Over here we're going to create an IP address. IP address, we can go ahead and give it a, what are we going to give it? 192.168.6.1 255.255.255.0. That's going to be the IP address of the tunnel. We need to specify the tunnel source. My tunnel source is going to be gigabit 0/2. Tunnel source gigabit 0/2. Let me also do show IP route to verify something. Okay, so I am able to reach 12.12.12.12. So that's why I wanted to make sure that I'm able to do that, because the tunnel destination is going to be 12.12.12.12. Just wanted to verify that I was able to reach that before I do anything else. Okay, so we have created the tunnel. We can go ahead and exit, and I will need to go ahead and create the crypto policy, crypto IPSec policy. Let's call it use policy 6. Authentication is going to be picture key encryption. Let's call this 3 des Group number, that's 5. What else do we need to do? We need to do the hash and the 5. Lifetime is going to be the maximum. You can add whatever, 86400. Okay, so that is done over here. Now we need to do a crypto IPSec key. Let's go ahead and exit. So it is crypto IPSec key Cisco, and the address that I want to give it over here is going to be the same as the destination in the tunnel, which is 12.12.12.12. 12.12. Oh, we need to do, let's do Cisco 123 address 12.12.12.12. Okay. So after that is done, we need to go ahead and configure a crypto IPSec transform set. So we need to configure a transform set, and then we need to configure a profile and attach that transform set to the profile, and then we attach the profile to the tunnel. So that's how it works. Okay, so let's go ahead and start with the crypto IPSec transform set. We are going to just call it tset 6 ESP AES 256 ESP shot with HMAC. Okay, then that is done. Let's go ahead and exit. We are going to do the crypto IPSec profile. We are going to call this IPSec Pro 6, and we need to attach the transform set. Transform set, we call it tset 6. After that, we need to go ahead and go into the interface tunnel that we created. It was tunnel 6. We need to attach that profiles. So tunnel protection IPSec profile, and it was IPSec Pro 6. IPSec, I forgot the C. IPSec Pro 6. You can see that tunnel is up. So now we need to go ahead and do a similar configuration on our 12. It's just basically the opposite, and we need to match the policy, and we need to match the IPSec transform set. Okay, so for router 12, interface tunnel 12. Right, in tunnel 12, before we do that, let's go ahead and do show IP routes. Are we able to see? Yeah, we are able to see 5.5.5.5, which is advertising via BGP. Okay, and 6.6.6.6. Okay, so IP address for this one is going to be 192.168.6.2. We configure that for router 6. So if we do a show IP interface brief, is it in here? Yep, it is in here. So you can see that we configure 192.168.6.1. So it needs to be in the same network. So we need to configure that 6.2/24. Now we need to specify the tunnel source, which is gigabit 0/1. Specify the source. What do you think is going to be the source? 6.6.6.6 for router 6. Okay, so that is done. Let's go ahead and create the crypto IPSec policy. We can just say policy 12. That's fine. Encryption. What was the encryption that we made for our 6? We can just verify my configuration because it needs to match, and if it doesn't match, we won't be able to form a tunnel. So we say the encryption was 3 des, group number was 5, hash was MD5, the authentication was pre-share key, the lifetime we can say for 86, I believe it was 86,400. Exit. Then we can do a crypto IPSec key, and the key is going to be Cisco 123. It needs to match the same. Now the address though needs to be the IP address of router 6. Okay. Then we do a crypto IPSec what is it? We need to do the transform set. So it is crypto IPSec transform set. Transform set. We can just go T set 12, and this one also needs to match ESP AS 256 ESP SHA with HMAC. Then we can go ahead and exit and do the crypto IPSec profile. We are going to be calling this Pro or IPSec Pro 12. Okay, so that is good over here. Now we need to go ahead and go and attach the transform set. So set transform set T set, we call it T set 12. Okay, so that is good. Now we go interface tonal, I believe it's tonal 12, and we need to add that tonal protection, IPSec profile, IPSec Pro 12. Let's see what happens. We should form a we should be forming a tunnel, but we are not. So T set 6, that's 6, that's 6, 3 dash, 3 dash, group number 5, group number 5, okay, protection, Pro 6, Pro 12. This one was 256 ESP SHA with HMAC. 256 ESP SHA with HMAC. Let's see the Cisco 123. What do we call it here? Cisco 123. Let's go ahead and do and show crypto IPSec SA. Nothing. Debug crypto IPSec. Debug IPSec. Debug IPSec. Crypto IPSec. Errors. Show crypto IPSec SA. Nothing found. Did we do for router 6? Let's do a show run. This is about to get interesting, guys. Let's take a look. Okay. So, source. Did we not do destination? Let's go ahead and go config T interface tonal 12 tonal destination gigabit 0/1. Oh, source gigabit 0/1. Do show run. Did I miss anything? Let's go and see what people say. Nothing. I got 5 people on nothing. Okay. Did I miss anything? Where are my people? So let's see. tunnel source, tunnel destination. I did specify the destination. Why is it only showing the source now? Tunnel. Oh, we are in here. Tunnel destination 6.6.6.6. Oh, there we go. Okay. IPSec campus failing. Failed to peer at 6.6.6.6. Processing information mode failed with peer. And show IP, show crypto IPSec amp. If it's failing, it's going to be failing over here. It's saying that it's active though. So if it is active, let's go ahead and do show IP, show crypto IPSec SA. Okay, so we do have a tunnel. Let's say if I ping 6.6.6.6. Let's go ahead and do a show IPSec SA. Okay, let's see if I ping. I need to ping 192.168.6.1. 192.168.6.1. It's not going anywhere. So let's see. Crypto IPSec SA. The tunnel was not touched. You can see nothing was encapsulated, decapsulated. Local address 20.1.1.2. Okay, so the local 20.1.1.2 and show IP, show crypto IPSec SA. Okay, so I'm getting the IC mode failure. So let's see. It's giving me some information. So why don't we just go ahead and Google this crypto mode failure. Let's see what Google's saying. And yes, I do this all the time, guys. So let's go ahead and take a look at Google. Let's see what people are saying. Blah blah blah. Negotiating remote as well. Contact the peer. Okay, I am the own peer. So VPN client. No harm insertion. That's right. See a lot of. What do we see here? Let's see what we can find. Okay, processing of blah blah blah. Nada. So we did the. Let's go ahead and verify that we do have the same configuration. So we did. I don't. Is it with IPSec? I mean, the IC was formed. So I believe if IC was formed, that means that the issue is with the IPSec. So IPSec transform set. Okay. Show run. I am failing, so let's see what's going on over here. The mode is tunnel. ESP AES 256 Sherwood HMAC. So this is matching. The key Cisco 1, 2, 3. We have group 5, pretty sure key hash with MD5 and 3 dash. Policy number 6. So everything is matching. Hash, group, this one as well. So everything looks good over here. Let me do, no, not that. Let's do a show run again. Okay, 12. IPSec is good over here. The source, why isn't it destination? Source, the source for gigabit 0/2. That's good. 0/1 over here. 0/1. So what are we just say? Processing of information. Mode fair at peer. Let's see if we search this one. I already selected that one. Let's go here. Negotiating with the remote peer as well. So there is a configuration mismatch between local and remote sites. Verify attributes at both sites. I did. Tone this up as well, but the error keeps popping. It just keeps popping. Let's go ahead and take a look at this one. See what they're saying. It means that one side has a certificate and the other one does not. Okay, I know. This is fun. Anybody has found anything for me? Nope. Processing. Main mode error. This is main mode error. Fellow main mode suggests that phase 1 policy does not match on both sides. So I'm not getting that one. Show crypto. My state is active though. So SHA 3 dash. Let's go ahead and on my access list, what is router 13 doing? Enable config T. What if we do access list 1 permit 192.168.6.0? Are you with me on this one? I don't know. I'm just going to add that in here. What if we do still unable to ping? That's really odd. So I cannot get this tunnel. So failure processing of information mode fail with peer. Let's search this one. There's a lot of stuff. I want to click on all of them. Spiceworks. Let's see what Spiceworks has to say about this. Oh man, there's a lot. Okay. He put his entire configuration in here. Cool. We're not using CryptoMap. Can they ping each other? Let's see. So from R6, ping 12.12.12.12. Yep. Oops. So yeah, I'm able to ping each other. So I'm able to ping from R6. I'm able to paying R12. So we have connection. So we do have a connection. So what if we, let's see, instead of using, it's still saying, let's do config G. Let's config G. Instead of the loopback addresses, can we use, let's just shut it down. Interface tunnel, this is tunnel 12, shut it down. Config G. Interface tunnel 6, shut down. No shutdown. No shutdown. Looping 168.6.1. Nothing. Okay. So insert. What about this one? Okay. Is it because of Pat? Come on. Oh. Okay. I think I remember this. Now that they're talking about translation. There it is. Transport mode must be used when a device is behind NAT. So let's go into crypto IPSec. Is it in the in the profile? Exit crypto IPSec profile pro IPSec pro 12. No, we need to go exit crypto IPSec transform set T set 12 mode. ESP AS256 ESP shot with HMAC mode. Okay, we need to do a transport mode because I'm using NAT. Crypto IPSec transform set let's go ahead and just exit so we can get the help command. Crypto IPSec transform set T set 6 and ESP AS256 ESP SHA with HMAC mode. Mode transport mode. Interface tunnel 6 shutdown. Interface tunnel 12 shutdown. No, shut down. No, shut down. It is, I still get the same error. Looping. 6, that's 6, that's 6, that's 6. That's fine. 192.8.6.1. Nada. Processing of information mode fail. And show run. And I believe this is because we are doing the NAT. So NAT is messing everything up. If I remove NAT and do a blah blah blah, it should be good. Let's go ahead and go right here. I mean, I changed that to transport mode. These are 12. Yeah, I'm using a profile. I'm not using a crypto map. So remote. So the port, I think it needs to be 4500 if you're using NAT. I verify that. Ports 4500 IPSec. NAT traversal. So why are we not using we should be using NAT 4500 because I'm using the transport mode. Am I right? So PAT is used to provide blah blah blah. ESP protocol without ports that prevents. Oh, here we go. Because there's no port to change the ESP packet, the binding. Hello's NAT T. If an device has been determined. Okay. 4500. NAT encapsulate the packet. Let me see one last time. So for R12 is not using system port 500. What are we using down here? Do show crypto IPSec SA port 500. Here's what we are going to do. Let's go ahead and save it. Save it. And we are going to reload. Let's go ahead and reload these two bad boys. Take a little bit. So thank you guys for tuning. Who we got? We got 6 people in here. We got Chris P. We got Almighty Mac. We got Matt Dix 12. We got Amen. Amen Ula. Is that how you say it? I don't know how you say it. I'm sorry for that. Who else we got? Who else is in here? Chris P. How you doing? Doing it live. This is why you shouldn't do IPSec in a live video. But hey, troubleshooting. Always reboot. Always reboot. If it's not working. If you think it should be working and it's not working, reboot. Reboot. I mean, because I can. Well, 12 is down. I can always create a tunnel between our 13 and our 12, and it should be fine because we're not using PAT. But because we are using PAT, you see, when a packet source and destination port of 4500 is sent through PAT, the device inside to outside the PAT will change port to 4500 to a random high port while keeping the destination of port 4500. When a different NAT session passes through PAT, it will change port to 4500 to a different random high port. So that's what's going on. So we need to make sure that we are using that. But obviously NAT, standard IPSec use over UDP. So it will be like this. If B, we have inform source that respond from the server. Got you. Yep, definitely this is tomorrow. I need it right now. So that's all it is. Full port 4500. Let's see after we reboot. Hopefully we get. No, it's still getting the same errors. You can see it right here. What if, since R12 it's not using, okay, let me just one last one that I'm going to be doing. Config T. Crypto, my head hurts. IPSec, transform set, T set. I'm glad I kept these names. ESP, AES 256, ESP, SHA with HMAC. Mode, tunnel mode. Isn't that going to mess it up? No. Let's do interface. Now we're still getting the same error. Tunnel 12 shut down. Enable config T. Interface tunnel 6 shut down. No shutdown. No shutdown. Interface is up, and what? Give me that error. Give me that error. Where's my error? And show not show IP. Show crypto IPSec. Do not give me the error. Do not give me the error. Okay. Okay, we're using port 500 right here because we're not using the same. So do show crypto IPSec SA. Still port 500 over here too. ping 192.168.6.2. Nothing. Yep, still not working. I'm probably gonna have to redo everything, but there you go. What I'm going to be doing, I'm going to be doing another video, so that is good. I get to do more videos. Thank you, Chris P. Thank you, Almighty. Thank you, Amen. Thank you, Matt Dex 12 for tuning in. So in the next video, we are just going to troubleshoot this IPSec. I don't want to make this video any longer. It's like an hour and something, an hour and some change, an hour and 10 minutes. Oh my God, YouTube is going to kick me out. Thank you, Almighty. Yeah, but I wasn't able to. I am now going to sleep. I'm now going to have a headache. I just going to come back to this tomorrow, and hopefully I'm able to fix it. So, well, we are first going to try tomorrow. I'm just going to recreate this again. See if that works. I don't know. It's not working. But well, thank you guys for watching. And if you guys like my troubleshooting, even though I didn't fix anything, if you don't follow me on Twitter, go ahead and follow me on Twitter at CCNP Daily Tips. If you have a Twitter account. If you don't have a Twitter account, go ahead and create one. Go ahead and create a Twitter account. And then follow me on Twitter at CCNP Daily Tips. Thank you guys for watching.